Up to this point, we've been working in 2 dimensions, which are just flat shapes, and we've been able to find area of 2 dimensions. Well, today is a big moment for us because we are leaving the world of 2 dimensions and we are going into the world of 3 dimensions. And just like we were able to find the area of a 2-dimensional shape, we are going to be finding the surface area of 3-dimensional shapes. So what does that mean? Well, it means that we're going to calculate the area of all the sides and add them together into one piece. Now, we could calculate the area of the top, add it to the area of the bottom, add it to the area of the front, add it to the area of the back, add it to the area of the side, and add it to the area of the side. But that's very long and cumbersome, and it allows us some opportunities to make some mistakes. So mathematicians decided, okay, there's got to be an easier way to calculate this surface area. And so what they said, well, what if we open up the shape and we take it back to 2 dimensions? If we have it in 2-dimensional shape, then we can start to look for common shapes we recognize and use formulas for those. So this is our cube, which is made up of all squares. When I open it up to its net, I can see one long rectangle made up of 4 squares, and I see a square on the top and a square on the bottom. Now, we know when we fold that up, it automatically makes that 3-dimensional shape. So honestly, I've just memorized what the net looks like. And when I go to draw the net, I just draw one large rectangle and I separate it into 4 equal-sized pieces. And then always on the ends, I draw my bases for my prism. Now remember, prisms always have 2 bases that are the same shape, and then they have usually rectangles for their bodies. Cubes are a little bit different just because a cube is made up of all squares. All right, so how does that help me when I go to calculate the surface area? Well, I break my surface area into pieces, and I think of the area of the bases plus the area of the body. Now, because we're working with a cube, every single piece is the same size. So when I do surface area, and I usually shorten it to SA because it's just easier to write, I really only have to find the area of one of the sides, and that would be base times height, and then I'm going to multiply it by 6. Now notice, I said area squared. The reason why is because my base and my height have to be the same number. So in this example, my cube, my base is 3, my height is 3. They're the same number. So if I just take 3 squared, that would be that area squared. That's one of these sides. Now, how do I get all the sides? Well, there's 6 sides on a cube, so I'm going to multiply that by 6. We only have to memorize that formula for the cube, so the cube is really easy for us. So if I take 6 times 9, I know that the entire surface area, so it's all 6 sides, when their individual areas are added together, they equal 54 inches squared. So there's my cube. Now, the cube is the easiest. Let's go ahead and take a look at a rectangular prism. Now again, it's a prism because it has 2 bases that are the same shape, and then it has my body. Notice it looks identical to the cube. It's just that on the cube, these were all squares. On the rectangular prism, these are all rectangles for that. Now, I could have rectangles as my bases. In this particular rectangular prism, I have square for my bases. So we just have to pay attention to that. But once again, I just know what the shape looks like. So I know it's one long rectangle with 2 squares. So I just draw one long rectangle, separate it into 4 sections, and here are my bases. Now, think of your sections as the front, the bottom, the back, and the top. That's how we're looking at those. And then these would just be my base areas. Well, say this is my rectangular prism. When I break it apart, I kind of turned it so I could show it with this viewpoint. Well, this 12 represents that 12 right there. And when I pull this front down, that is my 2, which is my front. Then my bottom's length is 9, my back's length is 2, and my top length is 9. And you're always going to see that there's a pattern with rectangular prisms where I see 2, 9, 2, 9, and it's because we're looking at the front, the bottom, the back, the top, and the front and the back go together, and the top and the bottom go together for that. Now, when I look at my bases are the things that were the same. So this is a base and this is a base. So my base is 2 by 9. So those are a little bit different when we go to do our formulas. So when we go and start to plug it in, remember, it's always area of the bases, and I have 2 of them, and I'm going to add that to the area of the body. Well, remember that body is like a rectangle, and I know area of a rectangle is base times height. So I start to put it together. So I start with my base. Well, one base to find that area would be 2 times 9. But I have 2 of them, so I do 2 times 9, but then I multiply it by 2. Now, my perimeter, I'm going to pull together this pattern. So 2 plus 9 plus 2 plus 9, because I want to get the whole base together. So when I do that, I get 22. Now that height of that rectangular prism is 12. So I'm going to multiply that by 12. So this is really just the rectangle, and then these are the bases here. So when I do this, I end up with 36 plus 264. When I add those together, I get 300 feet squared, and it's still feet squared because it's area. That means the surface area, so all the outside space added together would equal 300 feet squared. Now we can also have a triangular prism. And this is where we really start to see our bases, because our bases here are triangles. They're very distinctly different than the cube and the rectangular prism. But notice the body is still a rectangle. So when I take my triangular prism, I still have my rectangle as the body, because you always do with prisms. And then here are my bases. So I'm just breaking this apart. Well, when I break it apart, I can see that this is a base and the back is a base, because those are my triangles. And so when I take a look at that, my bases are 12 by 5. Now this honestly is the hardest part, is breaking it open. If you don't have very good spatial awareness, it's really hard for you to peel it open, which is fine. It might take some work, but you'll get it. Now my body, here I can see I pulled this side down, which is 12. Then I have my 5, and I pulled this side down, and that's my 13. So again, I go back. I have 2 bases, because you always have 2 bases in prisms. My bases happen to be triangles. So the formula of a triangle is base times height divided by 2. So here you can see my base times height divided by 2. But I have 2 of them, so I'm going to multiply by 2. Well, these 2 2's will cancel out. So really, it's just my base times my height. That's where I'm getting my 60. So these 2 together equal 60 centimeters. Now to get my body, I got to get that whole base. So I do what my 12 plus 5 plus 13, and then I multiply that by 4, I get 120. So now I'm going to add my bases together with my body, and when I put those together, I get my surface area of 180 centimeters squared. And if we close this up, this is what a rectangular prism would look like. I can see my 2 bases right here, and I can see my body for that. So rectangular prisms are difficult just because each of the different types of rectangular prisms have a slightly different net. We always call the rectangular prism by the name of its bases. So this would be a triangular prism. This would be a rectangular prism. Cube is a little different because we just say cube. We can have any shape for the basis. So I could have a pentagonal prism, I could have a hexagonal prism, but these are the most common prisms that we find surface area for. So it is difficult, and you're probably going to struggle a little bit today, but keep at it, because you'll get better at it the more you do it. Good luck.